All right, we're going to talk about part 4 of motion, which is acceleration, which is when speed or velocity, which we learned about, changes. Okay, so here we go. Let's talk about this. In reality, okay, does a car always go 50 miles an hour? No, it's got to speed up, it's got to slow down. Does a rocket ship keep going forever and ever and ever? No, it's got to accelerate. It's got to go off of the ground. It's got to get speed. It's got to go up, and then it's got to get into space, and then it's going to be moving around. You accelerate all the time. You get up and you go from class to class. You're starting at 0. You start moving 1-2 meters per second, and then you slow down. That's acceleration. Nothing stays moving at the exact same speed forever. There's always some sort of force slowing it down or speeding it up. But basically what that's saying is that all objects wind up accelerating from time to time. And, okay, so what is acceleration? Well, that's where we're down here, where we say it's how quickly an object's speed or direction changes. And that's the key there, okay? It's whenever the speed or direction changes, okay? And it's how quickly that happens. Okay? So it's how quickly an object's speed or direction changes. In other words, it's the rate at which velocity changes. Okay? So already we know that we're going to use time in this because a rate is however long something happens over, or however much something happens over a period of time, and we're also going to use velocity. So we know from the definition already that the acceleration is based on velocity and time, or really more closely the change in velocity, but I'll talk about that in a minute. Okay, so how does something actually accelerate? Okay, 3 ways to do it. You can speed up, you can slow down, or you can change direction. Let me explain this a little bit. If you're speeding up, let's say we go with the car analogy here. Speeding up is just like hitting the gas pedal. I think that's gas pedal. Okay. I think that's the one you guys are most used to knowing. Okay, if you accelerate, you're speeding up, right? You're hitting the gas pedal, you're accelerating. But did you know that slowing down is also acceleration? When you hit the brake, you are accelerating. Acceleration doesn't just mean speeding up. It also means slowing down. Okay? Because an acceleration is a change in velocity. Okay? Anytime there is a change in velocity, you are accelerating. Anytime. If you're speeding up, you're accelerating. If you're slowing down, you are accelerating. It may not be the way that you normally think about it in real life. It may not be the way that most people talk about it, but it's true. Slowing down is a change in velocity, so you are accelerating. It's a negative acceleration typically, but it's acceleration. This would be more of a positive acceleration, and this would be more of a negative acceleration because you're slowing down. But there's one more. Notice, change in velocity. So if the speed changes, you get an acceleration, but velocity also has to do with the direction. Therefore, if you change direction, you are accelerating. Even if your speed is the same, even if you're going 50 miles an hour and all you do is turn the steering wheel. Okay? You might want to write this down, by the way. If all you're doing is turning the steering wheel, you are accelerating. You are changing your velocity. If you're in a car and you're going 50, or let's say you're going 5 miles an hour and you're just driving around in circles in the parking lot, you are accelerating. Even though you may be going at a constant 5 miles an hour, you're still accelerating because your direction changes. At one point you're heading toward the north end of the parking lot, and then a couple seconds later you're going toward the west end of the parking lot. Then you're going to the south. Then you're heading toward the east. So you're changing your direction. That's acceleration. If you change your speed, either speeding up or slowing down, or if you change direction. So all you have to do to accelerate is turn that steering wheel or speed up or slow down. I think I've said that enough times. Let's move on. Okay, now let's redefine some terms here so that we can get to the math. I know you're looking forward to the math so much. So, speed, we already mentioned that it's the rate at which distance changes. Okay, and when we did that, we said that really what we used is d over t. Okay, it's the rate, that's where the over time comes from, the divided by time, at which distance changes. Okay? And when we did velocity, we did the same thing. It's the rate at which distance changes and in what direction. So for velocity, it's the rate at which distance changes. So it's the same thing. We did the rate, that's divided by time, at which distance changes, but we also had to add in the direction. Okay? Whether it's north, south, east, or west, or whatever. So that's velocity. Okay? Now, acceleration is different. This is the rate. Okay, it's rate, so it's going to be something over time, and it's the rate at which velocity changes. So we know our equation is going to have some sort of v over t, velocity over time. In other words, the change in velocity over time. Here you may have covered 10 meters in 1 second. That was 10 meters per second. That's how much your distance changed. Here you might be going from 20 miles an hour to 40 miles an hour in 10 seconds. That would be 20 to 40. That's 20 miles per hour per 10 seconds. It's 2 miles per hour per second. That's the rate at which the velocity changes. Okay. All right, so then the question becomes, well, how do I actually find the acceleration? Okay, we already just looked at it. It's going to be something like v over t. Okay, something like that. But we need a little more detail here. Okay, so what is acceleration? Well, we know, what we do know is that acceleration, and we're going to do a bar. That's for an average acceleration. Acceleration is just the change in velocity over the time. Okay, now if I'm a scientist, I'm going to be lazy, I mean efficient, so I'm going to change that up. I need to make that simpler. Okay, so I want to do, let's see, change in v over t. That's still too much work. That makes my hand hurt. So I, as a scientist, they figured out there's a better way to write change in, okay? And that is using the delta sign, which is just a triangle, okay? So acceleration equals delta v over t. So let's make a little side note here. Delta means change in. Okay? So in other words, when we look at all of this, we can say that the average acceleration of an object equals the change in velocity over time. Okay? That's one to put in your essential equation sheet. Okay? I'll go over some examples in the next vodcast, but for now, here we go. Am I missing anything? Ah, yeah. So here's the thing, though. How do you calculate the change in velocity? Let's say you go from 20 miles an hour to 40 miles an hour. How do you do that? Well, what you would wind up doing is you would take your velocity at the end, which was 40, and subtract the 20. So let me just sort of set this up here. You're in a car. Oh boy, now I have to draw cars on this thing. Let's see. It's not too bad. Okay, and you're moving with, let's say, a velocity of 20 miles per hour. And then later, you're in the same car. Yeah, right, like I'm going to be able to draw the same car. Okay, and you're going now 40 miles per hour. Okay, you want to figure out what's the difference between this and this. Okay, what's the difference between 40 miles an hour and 20 miles an hour? You guys all know, you just subtracted, right? But you need to subtract this one from this one. So here's what we do. Okay? We have an equation where we say that delta v, or the change in velocity, equals the final velocity minus the initial velocity. Okay? So in this case, this right here is the final velocity. That's the velocity you were moving at the end, and this is the initial velocity, the velocity you were moving in the beginning. That's all, okay? And the thing here, when you label these, so in this case, your delta V would be 40 minus 20, which would be 20 miles per hour. That is your change in velocity. That's how much it changed. You went up 20 miles an hour. Now the key here though is that there's the V, that's a lowercase v, but then the F and the I, they're going to be smaller and down. It's called a subscript. Okay? And you just make it a little bit smaller and down. So VF would be your final velocity. And then VI is what's called, that's an I, your initial velocity. Okay? So your velocity at the beginning, your velocity at the end. And so another way to write this then, to put in your essential equation sheet, is that the average acceleration equals, well wait, we can substitute in for delta V. We can say VF minus VI. So we can say it's the final velocity minus the initial velocity. Go ahead, come on, make the dot, there you go. Well, whatever. Divided by the time. And that's another good one to put in your essential equation sheet. Okay? Next podcast will be examples and how to do this, but for now, that's what you need to know about acceleration.